This is Unit 4.2, Soil Formation and Erosion. Soil begins to be formed with physical weathering of rocks. So this begins with mechanical breakdown of rocks and minerals. Abiotic causes of physical weathering include water, wind, and temperature variations. Changes between hot and cold will cause minerals to break apart in rocks, and that breaks the rocks apart themselves. Biotic causes, plant roots can break rocks over time. Burrowing animals, maybe not so much breaking rocks, but they do help break down soil into smaller pieces. You can see in this little diagram the way that temperature variations can also break rocks is through the collection of water in a crack, where the water freezes and expands and breaks the rock apart further. The ice thaws, water gets deeper into the crack again. This expansion and contraction cycle ends up breaking the rock in half. An important part of this physical weathering is the increase in surface area. So that causes more exposed surface and increases the weathering rate. Increased surface area eventually leads to chemical weathering. So this is a change in chemical composition of mineral compounds, carbonation, hydrolysis, oxidation. This can only happen on the surface of the rocks. So as mechanical weathering, physical weathering creates more surface area, that increases the rate of chemical weathering. The chemical weathering releases essential nutrients from rocks as the minerals get broken down. Things like phosphorus get released. Sulfur can get released too. And so this is a really important part of the phosphorus cycle, going back to the biogeochemical cycles from Unit 1, where the weathering releases the phosphorus from the rock, and then it can become available to plants that are growing in the soil. There is chemical weathering that can be caused by humans, of course. So if there's human-made sources of emissions, right, sulfur dioxide and nitrogen dioxide, that can pollute the atmosphere, which results in things like acid rain. And acid rain is really good at weathering rocks. So you can see this chain of events here. Fossil fuel combustion leads to sulfur and nitrogen oxides, which reacts with water vapor to form sulfuric acids or nitric acids, and that results in acid precipitation. And we are going to come back to this when we get to air pollution in Unit 7. We can see the effects of acid rain. It causes more acidic soil. It can impair visibility. It affects human health, increases the incidence of asthma and bronchitis and emphysema. It can destroy statues, right, made of limestone or marble, which chemically weather more easily than other materials. So how does this result in soil development? Well, the physical breakdown of rocks creates primary materials, raw material for the soil. So if you're looking at this diagram, you can see immature soil on the left, where there's lots of unweathered rock and some partly weathered rock. But then as the rock becomes more weathered, usually due to water infiltrating the soil to cracks in the bedrock, it weathers it further. Plants start to grow, and then the plants start to break down the rocks further and create topsoil. Also, the plants will decay, and that contributes organic material to the soil. So this is what we're talking about from above. Deposition of organic material from dead organisms also helps create soil. So let's look at two different soil profiles. So consider these. They just happen to be from North Carolina. So young soil in North Carolina, you can see they're not very well developed horizons, right? It all looks like kind of the same soil. Not much of it is weathered. It's maybe slightly leached, right? Leaching is where water infiltrates the soil and carries away nutrients to different places. And then the solemn is the surface and subsoil layers that have undergone the same soil forming conditions. So the base of the solemn is the relatively unweathered parent material, but solemn is not the same as soils. There's some soils that include layers that haven't been affected by soil formation. In old soil in North Carolina, instead there are well-defined horizons, right? You can see the difference between like the darker material at the bottom, lighter material at the top, and then again the brown, more organic material at the very top. So well-defined horizons. It's fairly weathered, highly leached, right? There's not a lot of nutrients left in some of those, and the soil is fairly thick. So mature soil has more organic material, more nutrients, but very old soils could be nutrient poor if the nutrients have been leached out. So I've been using the word horizons, and we're going to look at soil horizons. The ones that we're primarily concerned about are O, A, B, and C. Sometimes you'll see E and sometimes R, but we're not super concerned about those. So the O horizon stands for organic, composed mostly of organic material from dead plants and animals, right? So decomposed. The lower, most decomposed part is called humus, and this is mostly pronounced in forests, mature forests. The A horizon is the topsoil, and so this is at the top. There is some mineral material, and it's mixed with organic material, but not as much organic material as in the O horizon. And there's a fair amount of biological activity in the topsoil, so you get things like worms and invertebrates and moles and things like that. This happens in the A horizon. The E horizon you'll see sometimes in acidic soils where metals and nutrients have been leached from above and then concentrated in that E horizon. But you don't have to know that one for the AP test necessarily. On the B horizon, what you do need to know for the AP test is primarily mineral material, where metals and nutrients have accumulated, where they've been leached from above by water. And then finally, the C horizon is the least weathered, very similar to the parent rock that the soil is derived from. In this picture, you can see the fairly well-defined like ground surface A horizon. A horizon is dark because it has organic material. B horizon, not as much or almost no organic material, and the C horizon, which is barely weathered at all. If you go to the very bottom, sometimes you'll talk about the R horizon, which is unweathered parent material, also known as bedrock. So this is a good example of how you can see the different horizons. So different biomes will have different soil profiles, as in not every horizon will be the same thickness in the same place everywhere. So for example, in forests, like we have here in Maryland, you'll have thick organic layers due to leaf litter, and sometimes you'll have the E layer due to leaching. Coniferous forest soils also have some of these layers, although not as much because of lack of leaf litter. Grasslands have very thick topsoils, very thick A horizons. Rainforests have a very thin organic layer, which might surprise you, but the fact is the rainforest plants use up nutrients very quickly, or they take them up very quickly, so there's almost no chance for topsoil to form. In the desert, where there's no leaves and very little organic material, there is no O layer, and the A horizon is very thin, and the B horizon is much thicker. What we see, which is unfortunate in rainforests where there's slash and burn agriculture, the O and the A horizons are not thick in rainforests. So it's really, you would think it's a bad idea to slash and burn them to try to use it for agriculture. But what happens with the burn is that the nutrients that are in those trees and plants end up in the soil after the burn. Part of the problem is that once those nutrients are used up, then nothing's replacing them. So if the land is used for agriculture, nutrients are only there once and then they're gone. So that's one of the major problems there. So what are some services that soil provides? Think back to ecosystem services generally. There's plant growth, right? Soil allows plants to grow in it, so that's one service soil provides. It facilitates cycling of nutrients because there's a place for water and carbon and other nutrients to be stored when plants and animals are not using them. It provides habitat for certain animals, usually things like worms and burrowing animals. It's even an engineering medium. So humans use soil as a way to build things and cap things. So we will see that. Finally, soil provides good filtration and water storage. In terms of aquifers, you can have superficial aquifers that are somewhat in soil, and bedrock, fractured bedrock. And then soil is a really good filter of water. So water that might be a little more polluted when it falls on the soil leaches out some of those materials from the water. The water in turn leaches out materials from the soil, but the water usually ends up cleaner when it comes out the other side. One major problem we're having with soil is desertification. So, of course, there's no soil in the desert. And as the global temperature increases and plants tend to die off as their temperature zones change, more areas of the earth are becoming desert. It's also the issue where land that was once fertile is not fertile, and the soil degrades and is not replaced, and so therefore can't be used for agriculture anymore. All right, well, that is Unit 4.2, Soil Formation and Erosion. Please let me know what questions you have.